This is a video on how to get started on homework number 2. So the first thing you want to do is download homework 2 from Blackboard. Go ahead and save it. Probably want to make a directory called homework 2. Save it in there, and after it finishes downloading, you want to read through it. And you want to read through the whole thing at least once, so that you understand the scope of what's involved. So you got to do some book reading, which I already posted on Blackboard. You should have started on that. We have instructions, and we're talking about word problems. Word problems are a great way of translating, or a great way of developing your translation skills. You're going to have to learn how to translate real-world problems into digital code, and you also want to have a plan for doing that. While you're doing your homework, you want to make sure your number one goal is readability. Now, this is probably going to be new for some of you and very challenging. By the way, readability is a journey, not a goal. Well, I know that's kind of a contradiction, but it's a journey. It's something you always have to work at. And you're going to comment each problem with a comment block like this so that it's easier to grade. Now, it looks like we have 6 problems, and I'll let you read through those. What you're going to want to do is fire up Visual Studio. Here I've got Visual Studio 2012, and we're going to go New Project. And Win32 console application. We want to name it something good like Homework 2. I'm going to pause while that's created. Oh, I'll walk you through the steps on that one last time. Hope it's thinking. Yeah, it's thinking. Want to go ahead and click Next. And you want Empty Project. Turn off Security Development Lifecycle Checks and click Finish. And wait. So we've got our new empty project. We want to right click and add a new item. And we want a C file. Remember, you have to remove the .pp extension. We'll call this homework 2. Don't call it HW2, or don't abbreviate. Remember, proper case, prefixes, and all that wonderful stuff. Readability. Then we're going to switch over to the coding standards document, and we're going to scroll down to the bottom, and we're going to get our code template. And we switch back, and we'll go ahead and paste that in. And put in the comment information at the top. That's your name, not mine, unless you want me to get the grade. This is SET-151, and whatever your section number is. It's homework 2. This homework is word problems and decision statements. So we've got some wonderful libraries and our constants, and we're going to go ahead and run that just to make sure it works. And output window popped up with Hello World, and press any key to continue. So we've got that. We can close out of that window. We go back to the homework, and the homework says we need a comment block for each problem. So let's copy that comment block, and we'll get rid of the Hello World, paste that in, and we indent one tab. Remember, you always indent one tab inside curly brackets. That's called indentation to show scope, and it makes it easy to see where a block of code begins and ends. We go back to, oops, wrong window. We go back to our homework document, and it says write the code that will read in a floating point from the new user. Next, print the number in decimal notation and then in exponential notation. So I need a variable, and it says a floating point. So we're going to use a single float, and we'll call it SNG user value, and we'll initialize that to 0. Now, when we name variables, we use prefixes. SNG for single float, not FLT, but SNG. We use descriptive names. We use proper case. That's where we capitalize the first letter of each word, and we do not abbreviate. We need to print out what we want the user to do. So problem number 1, enter a decimal number. So we have comments so the programmer knows what's going on. We have a printf statement, so the user knows what's going on. We have two of those. And then we're going to need a scanf, and if you recall, the placeholder for a float variable is %f. Put an ampersand in front of our variable name. That looks good. Remember, you put an ampersand in front of the variable name for all variables except strings and arrays, and we'll find that out whenever we get to arrays and strings, which is week 7-ish, somewhere around there. And now we have to display the results in both decimal and scientific notation. So the number in decimal format is, and then % something, and in exponential format is, and then % something, not quite sure what. And then we're going to put our user value, and we're going to put that twice. And that line's getting a little bit long, so what we can do is we can just hit enter and bring it down to the next, and we have to go figure out what those placeholders should be. And so you can look either in the book or you can look on the internet. So let's go ahead and take a guess at those. We know we'll try %f for decimal, and we'll try %e for the exponential notation, and we'll see how that works. So the output window pops up, and I'll enter 1, 2, 3, 4, 5, 6. Hit enter, and it says the number in decimal format, I left that out, is 123.456.01. Notice the 001 at the end. That's due to round off error because it is stored as a binary fraction. And in exponential format, it is 1.23456e to the power of 2. Now that is a little hard to read, so we're probably going to want to break that line up. What we can do is, in the middle of that, we can put a /n. Now the problem with that is it doesn't look like in the code how it will appear on the screen. So in order to fix that, I make two printf statements. The first one with a /n, and because we have only one placeholder now, we need only one variable. And the second one, we pick up where we left off, and again we have only one placeholder, so we need only one variable. And so now we're going to print the information out in two lines, and the code mirrors what will be on the screen. So let's try that again. Drag that down, so put in the same number, 123.456, and I get the number in decimal format is, and the in exponential format is, and that's exactly what we want. Press any key to continue. Now we're going to start with problem 2. Probably want a blank line or two after a problem so that it is easy to see where the one ends and the other starts. So let's go look back at the homework, and it says there are approximately 3.156 seconds in a year. Write the code that requests your age in years and then displays the equivalent number in seconds. Assume 365 days a year. So go back to our problem. And a good comment for this is display age in seconds. So the first thing we need is a variable to hold year. So go ahead and make that a float, and we'll just put age in years. And we'll initialize that to 0. Now I see a whole bunch of bad code where people just put age or years, or see, a lot of times you'll see just abbreviations A. It's very common for C programmers to just use A. And then they'll do something horrible like this. They'll printf and they'll say, they won't even tell you what it is. They'll just put %f, something like that, /n. And then they'll say A, and then they will have figured out how many seconds are in a year. So let me show you how that they'll do that. They'll bring up a calculator. So here's the calculator. By the way, that's in the way you get to a calculator is Start, All Programs, Accessories, and the default view is Standard. What you can do is you can change that to Scientific. Believe it or not, the calculator that comes with Windows is one of the most accurate calculators in the world. And people back in the 1900s would have killed for something like this. It's extremely powerful and very accurate. So anyways, these C programmers say, well, there's 365 days a year times 24 hours a day times 60 minutes an hour times 60 seconds a minute. And then they copy that value and they come back to their code and they paste it, and they do all that at once. This is classic bad C programming. First off, it's not descriptive variable names. They're not telling you what you're doing. Oh, they had to read that in from the user, so they won't. So we'll do scanf, and they'll do %f %a. So they read it in, they don't tell you what they're using the number for, they don't tell you how they're using it, and then you're left to wonder what this crazy thing is, and they hardly ever give you comments. Now that is what a standard C program is like. You cannot code that way. Why? Because it's not in your best interest. If you do, you're going to have really messy, convoluted code that's hard to maintain and debug. And then you won't be able to handle large, complex projects, and you won't get much experience, and you won't do well in the business world. So I'm going to leave that there as an example of what not to do. What we want is something like float SNG age in years equals 0. Then we have to tell the user what we want. So printf, please enter your age in years. E.g., we'll give them an example, 4.5, because you know how kids, that half a year is a really big deal to them. Those were the days. So then we have to go ahead and read what that age is. Now remember, just placeholders in your scanf, nothing more. Ampersand, SNG, age in years. There we go. And then we have to do the math. And this number, I have no idea what that is or where it came from. But if we comment it, like 365 days per year times 24 hours a day times 60 minutes an hour times 60 seconds per minute, we get S&G seconds per year. Now we're going to want that variable for readability, so we're going to come back up here where we declare our variables and put it up here, and we're going to make that equal to 365 times 24 times 60 times 60, and the computer will do the math for us. And seconds per year, we'll take that comment block and move it up here. Whoops, where'd it go? And move it up here with us. In fact, I'm going to put that before age in years. So then I see programmers do this. They say printf, your age in seconds is, and they say %f. Oh, I forgot to put problem 2. Problem number 2. And so then they put S&G age in years times S&G seconds per year. Oops, come on. Now this is what I call fancy coding. Why? Because you're doing two things at once. You are doing a calculation and you are displaying. My general rule of thumb is I try to do one thing per line, and that serves me really well. Now when it gets compiled, that is translated from source code to machine code, it's going to break it down into individual items. So it's going to do one statement at a time. Can't do two things at once, at least not yet. So it doesn't do us any good to try to do fancy coding. In fact, it makes things worse. So we need another variable. Here's something else not to do. What I do is I see that oftentimes programs will say age in years equals age in years times seconds per year. Once you multiply your age in years times seconds per year, that is seconds in year, or age in seconds. it's no longer correct to store that in a variable named age and years. What you need is another variable. Now there's only two reasons not to make another variable. You know what those are? Ignorance and laziness. Or apathy. Let's call it apathy. Either you don't care or you just, yeah. So we need another variable, age in seconds. Remember, this is all about readability. So come up here, float. Age in seconds equals 0. Go ahead and put age in seconds, and then we put this here. And there we go. We can compare my code to the original block. Now, the original block, yes, is much less code. My code is more, but after it compiles, it won't really matter that much. Now, I have a question. If there were two projects, Project A and Project B, and the first project had, I don't know, say 3,000 lines of code like this, and the second project, Project B, had 10,000 lines of code that was written like this, which project would you rather be on? The first one, A, or the second one, B? Yes, most people would choose Project B. So let's go ahead and get rid of what not to do, and we'll keep seconds per year, and we'll go ahead and run this. Now last time it was getting mad at me because I had to declare all my variables at top. Yeah, so I must declare all my variables at the top. So I need to bring some organization to the fray. And so I'm going to comment these. Problem number 1. And then this is, of course, problem 2. And I will continue that on. And now, let's put another blank line between these and button this up. Remember, readability is our number 1 goal. We want it to look good on the screen and in the code. Oh, it's still mad. What did I do wrong? Missing type. Oh, I moved all the code, not just the variable declaration. Yeah, I was doing that on purpose, just to make sure you were paying attention. So 123.456, that worked correctly. Age in years, we'll put in 4.5. And your age in seconds is, that didn't work so well. Oh, because I didn't put a format specifier. We need to do F. Now, after you get a problem working, you may not want to keep entering input in that, especially since there's problem after problem. So, debug temporarily, you can comment out working sections of your code and just concentrate on the problem you're working on. And after you get that finished, you can move the closing multi-line comment block down, and you keep doing it. Now, when you're all done, make sure you get rid of those, but that's an example of how to use the multi-line comment blocks to help you debug. This time it's going to ask me for just age in years. So 4.5, and apparently that is what, a billion seconds? 141 million seconds. That is pretty cool. And that is problem 2. Then of course you'd start, oops, got indentation problem here. We'd start off with problem number 3, and you'd have to go look up whatever that is, type something in there, and then you want your printfs so that you have some nice blank lines between problems, and you probably want to move your comment block down, and that is how you get started on homework number 2. And that's the end of this video.